Alright, time for another DraftPhysics.com video presentation. I guess we could go to this. Anyway, overview video. So we'll go over, instead of going over the videos, I'll just go over the ideas, basically, that were in the videos again. Probably, hopefully, better than I did in the videos. But they're all good videos. One of them kind of an aberration. During the week I talked a little bit about photons and radar and how it's possible to kind of provide more evidence regarding photon as a particle versus photon as a wave thingy, and how there is experiments they could do that would sort of provide enough information to draw a more reasonable conclusion than the kind of silly idea that it's both particle and wave. That if there is any wave part, it's because the particles are waving, frankly. That's the real truth. But anyway, it doesn't mean anything to be waving. Okay, it really doesn't. When you're independent, when you're not glued to each other, the particles, like water, or even atmosphere under pressure. So anyway, I guess I should just mention there was the one video that wasn't on the kinetic energy subject. And the kinetic energy subject really is about gravity, is where it starts. I mean, that's where the first mistake is. So I did talk extensively earlier in the week about gravity. And then we ended up on levers and gears, which is always sort of is those devices. Any conversion device basically proves kinetic energy doesn't make any sense. So you could include springs and magnets even in there also. So I guess we'll just get to it. Other worth mentioning news. I should be talking to what's his name again? Oh, jeez. I can't remember his name. Toady, that's it. So soon, coming soon. Should be another conversation, and probably will be about these kind of subjects, about how, there's a logical proof. I mean, we have a lack of evidence, and that should be fixable, because, frankly, there's some experiments that are so simple. I mean, you're just talking about levers and gears. They're really simple experiments, and they should be able to prove one way or the other what the outcomes are, even though I would argue the theoretical and logical proof already exists. And it's intractable. You can't, you can't dispose of it. They're solid arguments. So anyway, on to where it starts. So it starts in the 1600s with the idea of gravity, I think, is where all this goes wrong. And so there's some idea that, you're sitting on the earth or whatever, standing, blah, 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 it doesn't matter. All right, and there's this idea that there's this force of gravity, that's constant. And their perception is that every, 5.8 meters, you'll have some sort of counter force of 9.8 meters per second of force. So, you go from 0 to 9.8 in 5.8 meters. It takes that much of a drop for you to finally get to this velocity. And then that happens every 5.8 meters. Every 5.8 meters, you'll get another 9.8 meters of velocity. And every 5.8 meters, you'll get another 9.8 meters of velocity. And I'll do one more just to prove the 4 times versus the 1 time height, right? So 9.8 for 5.8. So this is how they think gravity works. Now, they really can't think this way because there's so many facts that make this untenable, because you never acquire this velocity over this drop. So if I do this total drop, I'll never get 9.8 plus 9.8 plus 9.8 plus 9.8. That ain't going to happen if I drop something from that high. And so it's already telling you that's not true. But they want to make it seem that way. So they're basically saying that, okay, the two-mass object, with this two mass here, And it doesn't matter. I could have a 2-mass object here, right? So it doesn't matter what the mass is, any mass. The fact is that you have to lift it, okay, 4 times higher to double its velocity. So you don't get any of this. This doesn't happen every 5.8 meters. And so when it looks like, okay, this is 4 times the distance, so it should be 4 times the energy here, right? So I traveled 4 times as much distance. But the trick is, okay, is that this distance and this distance are equal. But this distance, okay, that's not half. That's not just the same little piece. You're going much faster, okay, not 9.8, but you're going 18, you're going, let's just for the sake of argument, you're going 20, okay, meters per second by the time you hit the ground. So you've doubled your velocity, okay? You got your 9.8 here from dropping at 10 at 5 meters, 5.8 meters, okay? You got your 9.8 velocity here, all right, but you only have 20 here. So, 10 here, 20 here. So you only doubled your velocity in that whole 4 times the distance thing. So you're not acquiring this. And this number is going to change depending on how far I drop it. So if I drop it from even higher, all right, then I'm going to get an extra 5 of these things. So I'm going to go 1, 3, 5, 7, the odd numbers. So I'm going to travel 5 of these distances, all right, in the 3rd second. And I'm only going to get 9.8 out of it. So even though I'm going to go 5 units of distance more, 5 units, way up there, 5 units of distance more. Well, I could have wrote down here. Anyway, I'm only going to gain the one, it's just going to be 30 meters per second when I hit the ground. So even though I'm a preposterously much higher distance, 15 times the distance, right, almost, 12 times this and whatever, I've only increased to 30 meters per second my velocity. So clearly what gravity is it's a force that sort of rains down on us, and we collect it based on how much mass you have. You're just collecting an amount of force proportional to your mass, and so it's moving your mass. And say if it was we were just made out of little tiny particles like electrons and protons, you could understand they're all the same size, and they move at a constant rate. So if you hit them twice with a little piece of raindrop, then they move twice as fast. And if you hit them with 3 raindrops, they move 3 times faster and 4 times faster. In fact, depending on how many raindrops they get hit by, will decide how fast they're going by the time they hit the ground. But it's all proportional because they're all in the rain. They're all going to get hit with a consistent amount of rain because they're really big compared to the rain, So if 2 people are standing in the rain, you could understand they're going to approximately get hit by the same amount of rain, and it's all just dependent on their mass, and so they're going to be pushed by it the same amount. And that's clearly what's going on here. That's why things fall at the same rate, is because they're made out of these elemental bits that are all the same size, and they're collecting it based on their exposure. How much time are you standing in the rain has how wet you're going to get, and that's all that's going to decide. So it's clearly just about time. It's about time. How long does it take you to get to a location will tell you how much you're paying per foot. So it changes. It's completely variable. The higher I shoot for, the less I pay for each foot. The less energy I use per foot. I use more real energy to get to a higher place, but per gallon, I'm getting better fuel economy. So instead of 10 miles per gallon, I get 20 miles per gallon, or 30 miles per gallon, or 40 miles per gallon. Depending on how fast I can get through the gravity will decide how much gravity I have to fight. And that's all it's really about. And the simple example is the planet, and you can just sort of understand that the faster I go by the planet, the less it bends me. So the slower I go, the more I'm going to get bent into the gravity. The faster I go, the less and less the gravity affects me, because it's really just about what amount of time you spend being exposed to it. So I compare that to being sunburned or something. How much sunburn you're going to get going by the sun. If I shoot by the sun, on my rocket with a lounge chair, depends on how fast I'm going. It's going to tell me how much sunburn I get, right? If we forget about gravity and just go with the sun, how much exposure. And gravity's the same thing. It's just an exposure going in. Sunlight goes out, well, gravity goes in. And it's by the same inverse square rules. and it's clearly a time component. So it's just about time. So this is where mv squared comes from. It's this weirdness. Hey, it's 4 times the distance, and you only got twice the velocity, right? So they ignore the twice the velocity part. Just go, hey, it's 4 times the distance, so it must be 4 times the energy. You fell from 4 times as high, you must hit the ground with 4 times the energy. And no, it's only twice the energy, because it's only twice as much time to fall 4 times the distance. You do this distance in the same amount of time as you just do 2 of these if you were standing here, right? So you have to recognize that it's not per amount of distance, it's per amount of time. And the fact is that if you do drop it, it's increasing in its velocity, and the increase in velocity means it does the last second here, it does the first second this much. Big difference between the first second and the next second. 1, 3, 5, 7. The odd numbers. Galileo figured this all out, and apparently people just said, screw it. We don't really want to pay any attention to what's already been figured out, and we'll just go by this overt, simplistic visual. The weird and impossible visual. The visual says 4 times. You know, how can we deny the visual? The visual is so glaringly saying, this is much bigger than this. It's much more than 2 times. Therefore, it must be that this has 4 times the energy when it hits the ground. When, no, it only collected 2 9.8s. That's all it collected, 9.8 and 9.8. This one collected 1 9.8. And that's the only difference. This has 2 9.8s, this has 1 9.8. That's it, 2 times the difference. And obviously if I half the mass, I'm halving the amount of exposure it's going to get, so blah blah blah. So obviously if it was a 1/2 mass, that's 1/2 times this 2, right? And then you're back to 1, so it will be equal. So a half mass, 4 times the distance, same thing as a full mass, 2 mass, not 1 mass. Same energy when they hit the ground, because this collected 2 9.8s, but it's only got half the mass. So 2 9.8s times a half. Same thing as this. And it's perfectly logical. The universe works with this diagram. This model works. It explains the phenomenon. And it's just this. As soon as you start saying, oh, it's 4 times the energy, now you're just broken everything in the universe. Because you're exaggerating how much you're faking it. You're saying there's energy here that isn't here. Twice as much energy as the truth. You're that far off. And that's only an example from, twice the distance. If I do much higher distances, you're going to get more and more outrageous answers. So the bullet and the gun is the perfect example of just how outrageous everything gets. Because this is supposed to be. You still see that? I'm really going, stretching it. Anyway, there's supposed to be an equal and opposite reaction here. And yet you're saying 2,000 joules here, 2,000 watts, 2,000 units of heat are going this way, and only 2 are going that way. I mean, that's how outrageous it gets. So the more differential I make the mass, big mass, little mass, well, I got it backwards, big mass and little mass, the more difference I make in the mass, inversely, the velocities have to change proportionally, and your squaring of the velocity starts creating more and more outrageous numbers. And they just aren't true. And they've never been properly tested. In the places where they have, people just don't say anything. Like NASA knows it doesn't work. Kinetic energy doesn't work. NASA knows this isn't true. 2,000 to 2. It knows it's just about the speed and mass of the particles it shoots out of a spaceship is going to decide which way it goes. And there isn't going to be any squaring of the velocity. Alright. So, part 1. I'll be back. Alright, so now we'll cover levers and gears and some of the theory behind that. Now, the evil Mickey Farley, the guy who attacks your personal security when, he loses an argument, He did actually make a civil video attempting to make some sort of mathematical argument that levers bend and that somehow that would account for somehow different amount of energy getting to an object, which is kind of silly, but we'll go through it. So anything that gets hit, any communication between one object and another object involves bending. I mean, springs bend, obviously. And every contact something has, it's already a proven fact. For example, I guess I'll draw it way down here, and then I'll know my drawing space. So I could take a steel bar and I can hit it one end with a hammer. All right, and the fact is the bar's gonna compress. It's actually going to get a little bit shorter because it's going to take time, like 5 times the speed of light. I mean the speed of sound, or something like that, 5 or 10. Can't really remember. But you know, it's much faster than the speed of sound in air, in steel. But at that speed, this compression will be transmitted. So there's a period of time, okay, time's important again, a period of time where this steel bar is actually shorter because this side has moved in, it got hit by the hammer, and this side hasn't yet because it doesn't really know about that yet. And so at the speed, so Farley is, you know, saying it's instantaneous. There's no instantaneous communication. I mean, that's already been proven. So it takes time for the knowledge of, you know, the compression of the atoms to reach this end. But you wouldn't really call that bending. And you really know that, well, yeah, eventually it's going to get here and it's going to push this out. So this end will move, and then this end will move, and this end will move, and this end will move. It happens eventually. It catches up. So you could argue that in a lever, okay, place the fulcrum. You know, so I have a nice bearing, and I just have a piece of steel. You could argue that when anything hits this side of the lever, it again has to move through this steel, or whatever, it's aluminum, doesn't matter, has to move through it at the speed of the sound inside the material. So, you know, a relatively fast speed before this side moves. Okay, so it takes a little bit of time. But you can't change anything that's basically happening with the lever. I mean, even if this side bent a lot, you know, even if it was like, it went like that, well, this side stays straight, and this side bends. That bend is going to push on this side eventually. This is the side that'll spring back, and it'll spring back. So it's like a spring. It'll store the energy. So you can't destroy the energy. You can only create some kind of system, mechanism that stores it, and then it's going to give it back again, just like a metal spring. I mean, you can use just a piece of metal, you know, thin metal. You can use it as a spring. It'll bounce and then bounce back. So, I mean, the fact that there's theoretically, technically, bending going on doesn't make any difference because it's conservative. It stores the bending and gives it back. And it gives it back to the right end, frankly. So anyway, so I think that's kind of a silly argument. And the rest of his argument was just, you know, he took down his video. So it was the only decent video he's made where he isn't doxing me or being insanely rude, and was actually making an argument, and he took it down. But it was a silly argument because he's trying to use all these technical proportionalities to trying to say this side doesn't have to do what this side does, and this side doesn't have to do what, yes, it does. All right, so the technical argument is that the lever is just a dumb thing. It can't differentiate. All it can do is move, you know, pieces of stuff. And so the idea would be is that if I was to throw a two-mass object, okay, drop it onto the lever here, the lever itself, this piece of metal, okay, this solid thing, will behave exactly the same whether I put a 2-mass here or I put a 1-mass here. It can't possibly tell the difference between those two. So this side over here, this metal, can't sense, okay, because it's sensing in the sense that it's going to send its signals and it's either going to get a response or no response. But the fact is that there's absolutely no difference in any piece of this metal. This molecularly, every single atom will move exactly the same way, whether I put a 2-mass here or a 1-mass here. Okay, so these are real notches on the lever, just understand that. This will move exactly the same. This little piece of the lever, like this atom right here, will move exactly the same whether I have a 2 mass here or I have a 1 mass here. Every single atom in this lever will move exactly the same. Now, you know, exactly within, I mean, very loose, okay? But yes, I mean exactly, okay, in the sense that exact within, you know, a billionth of a proton or something. I mean, you know, a tiny amount of difference. Each atom will do exactly the same thing. So there's absolutely no way for the lever to tell the difference between this and this. It's exactly the same thing from its perspective. It's going to move this, just as it's going to move this part of the lever exactly the same, this part of the lever is going to move exactly the same. So it doesn't matter whether the mass is here or the mass 2 masses here. This part of the lever, this little atom right here, is going to behave exactly the same way. It's going to cover the same amount of space. It's going to do exactly the same thing. So there's no way to argue that somehow the lever knows that I put a 1 mass out here and I'm fooling it, and now it's supposed to create 2 times the energy. It can't do that. It can just move the lever. So when I put a 2 mass here and there's no mass here, this part of the lever moves this kind of way, and that's it. That's all it does. And when I put the 1 mass here, it does exactly the same thing. Because it really doesn't make any difference whether you're moving this part of the lever or this part of the lever. They're all set to go a certain amount of distance based on their distance from this pivot. And they can't change how much distance they're going to move in how much time. And it's just a fact. This is deciding the movement, and every part of the lever is going to interpret that movement, and there's no way to change it unless I put a 2 mass out here. Well, then I really have a 4 mass, okay? And so that'll be gigantic. So obviously this might even bounce off because it can't lift the 4 mass. You know, so, but it's the same rules as collision. So this is just a conversion device. So you can just think of it as you're just really colliding masses with each other, you know, a 2 mass with a 1 mass, blah, 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 blah. And this is just a device for doing the conversion efficiently, where you can't just bang them into each other, because this is going to, let's say this is going 15 miles an hour, and the 1 mass, okay, needs to go 30. Well, the 2 mass can't do 30. It's not doing 30, it's doing 15. So it can only give 15. It can hit something, and now the thing it hits, it's now given 15 miles an hour to. It can't give 30 miles an hour. So it's stuck not being able to give the thing the energy. See, as soon as it gives it 16 miles an hour, this thing's going faster than this thing. You get it? I mean, there's no way I can keep giving it energy. I'm giving it energy. I hit it in the first instance. See, I could do a whole bunch of math. I could do a bunch of integrals and blah, 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 and like Farley, and say, look, math proves it. But the fact is that this thing's velocity is going to be converted, it's exchanged. It's giving its money away. And as soon as this gets richer, essentially, okay, than this, you can't give any more money. So as soon as this is going 15 miles an hour. Now it's going 14, okay, when it first hits, and then it goes 13. And this one's going up, exactly the opposite. So as this one's going down, this one's going up. And eventually this one's going to go faster. And it's going to go faster at something less than 15 miles an hour. At something less than 15 miles an hour, this thing's going faster than this thing, and they're not communicating anymore. This thing, you can't hit that thing anymore. So what a lever allows you to do is get out of that, you know, where you can't exchange the money. It's in the wrong denominations. And it just allows you to convert it into a mechanism that doesn't care. It just cares about the total dollars. It doesn't care whether it's $10 bills or $20 bills. It just cares what's the total money, and it'll do the exchange. And so levers do that. Springs do that. Okay, 2 facing magnets can do that. They can take the energy that between the 2 objects, and they can make exchanges between high velocity, you know, big mass, small velocity, and big velocity and small mass. They can make these exchanges, where just banging them into each other you can't, because the slow thing can't give a fast velocity, and the heavy thing, the slow thing can't give a fast velocity, and the fast thing can't give a fast velocity to a big heavy thing. And so these devices allow you to do that conversion. I can hit a spring with a very high velocity. I mean, it can't be bullets, right? But I can hit it with something pretty fast. It'll compress based on the momentum, the MV. And then I can put a big heavy thing on there, and I can just get the MV back and come out with a very small velocity and a big mass. And these two things will equal. I'll conserve the energy, I'll get it back again, and I'll just get it back in a completely different form. So it'll allow me to crash a little tiny thing into a giant thing and see what the results will be, because the spring can do the conversion. So yeah, even the bullet example on the lever, technically you could argue that it's going to bend the lever. Okay, it's the speed of the sound in the material, right? If I hit it with a bullet that's going many times faster than the speed of sound in the material, well then obviously the bullet keeps pushing because it's got a high velocity, so it keeps making exchanges, lots of exchanges very fast, and they're not getting to this end. So it literally is, this part of the lever starts moving and this part's not moving, and so it just breaks, it cracks, it splits. And that you see in the real world all the time, that fast vibrations can break materials because basically they can't transfer the pressure fast enough. If you move it faster than the speed of sound, then the pressure doesn't get moved fast enough through the material. It doesn't dispense quickly enough, and so then you end up with higher and higher and higher pressures building up, because you're not relieving the pressure by allowing it to move to where it's supposed to be, where it's going to go. It's not leaving the site of the explosion, so to speak, fast enough, and so it's piling up as higher and higher and higher pressures. Alright, well that's pretty good. And so maybe we'll just throw in a little bit about the gear and call it a video. Alright, so gears provide another way of just converting one speed for another speed. So gears, so just imagine them all the way around there, and then you have a little gear here in the middle. Okay, and you can turn it, okay, so you can turn it this way. And when you do that, you have high torque here, that is, you can apply a high pressure, because you have a small amount of movement. Alright, and here you have a large. So just imagine that this is a 2-to-1 ratio. That the distance from here to here is this is twice that distance. Alright, and so the simple thing is that yes, if I put a 2-mass weight here on one of the gears and just turn it from this position to this position, and then I put a 1-mass weight here and do the same thing, that I won't be able to tell the difference. So if I couldn't see the gears inside a box and somebody else was deciding whether they're going to put a 2-mass here or they're going to put a 1-mass out here, I wouldn't be able to tell that they made the switch. And you really can't use any bending argument here. There's not much room for any bending issues between this gear and this gear. But it's just a fact that, yes, and the argument is, obviously by the kinetic energy formula, 1/2 mv squared, okay, which should just be mv, is the simple argument. This was the right answer, and I don't know if they changed it into this for no good reason, really. There really aren't any good reasons. They're all just bad reasons. Because this works. MV explains this. This makes it nonsensical and insensible. Because the argument is, even though it will feel exactly the same, I will in fact do exactly the same work. And I can convert a 2-mass in here and 1-mass out here. It's basically a lever argument again, but it's obviously in a different form. And they will be equal. But this theory says this has twice as much energy. So this has twice the energy. Big E. There's real extra energy here. So even though it feels the same, even though exactly the same, I could have another gear on this, on a steel rod here, I could have another gear that is turned by some constant force, like, there's a rope tied to a goldfish, and the goldfish, races to his dinner dish at exactly the same speed every time, and so he's turning it. And the fact is that same force will create these two effects. I can move the one mass this distance, this 2x distance, or I can move the two mass, this half distance. And it's exactly the same thing. It's the same energy. So it basically is, you can't, there's no way to make any sense out of any argument that this flies off with twice the energy of this. They have to have the same energy because they're created by the same energy. The same energy creates both functions. This short travel of the two mass, this longer travel of the one mass, it's the same energy that creates them. They can't launch at different energies. They can't leave the gear, okay, with different amounts of energy, because the same energy creates it. And, it's sad that a mechanism this crude and simple could actually prove a 300-year-old theory to be nonsense, but it doesn't change that it's a fact. It's kind of disgraceful that physics has some inadequacies in it in terms of its capacity to check its own facts, that it wouldn't have checked them. And it wouldn't have checked them against the simple lever and a gear. Do they still make sense? When I made these changes, right? So first they made this change in the 1600s, 1650, well, 1668. They started to make the change. It really didn't start to happen until 1720, but regardless, it didn't catch on because the physicists said, yeah, it doesn't work. So they changed it to MV. From M. From MV, they changed it to MV squared. And for 100 years, it stayed that way, and then they put this half in front of it. But just imagine that through that whole period of time, this got even more outrageous answers. So for this gear thing, it would say there was 4 times the energy here that there was here. Even though you can know it's the same work, same turning force, same pressure applied, 4 times the energy. A silly free energy device. Silly amounts of free energy. It's not a little bit of energy. It's a huge amount of energy. 4 times the energy. It's a huge amount of energy. And obviously we couldn't make this, we can't, why would we bother with, we just hook up water wheels to each other with gears and we could be making all kinds of free energy. Just let the water turn a little one, turn a big one, and we make free energy. So it didn't make any sense, and then the opposite happens. It destroys energy. When you try to go the opposite way, you put in the 4 energy here, you only get your 1 energy out of here, so it destroys energy too. So it clearly doesn't work. It clearly breaks all this simple continuity. So it breaks levers, it breaks gears, and for whatever, 150 years they didn't do anything. And then when they finally did something to figure out, well, 4x is silly, that's just a silly answer, they put the 1/2 in front of it. Instead of just crossing that out, they thought they were going to fix it by putting another 2 in here under, as a denominator, like somehow that denominator is going to fix that outrageous square, and that didn't work. We just still get silly answers. But I'm just saying, it's just a fact. It just demonstrates that physics isn't as well tested as it should be. What they claim to be the truth isn't based on thorough investigation, thorough testing. They don't do any thorough testing because they've never done these experiments. They'll just say things like it takes 4 times more gas to go twice as fast. They won't test it. The 8-pound ball going 16 miles an hour has twice as much energy as a 16-pound ball going 8 miles an hour. Never tested it. They just say it. And it's incredible that they could make mistakes this big and get away with it, and still get away with it. I mean, that people are totally resistant to just accepting the truth that, yeah, that's an obvious fact. It's obvious that the physics isn't as credible as it should be. It should be built on a much solider, they should have done more work, verifying their axioms, verifying their fundamental claims about reality. And you can see it though. Wave-particle duality, bent space is an answer. What's gravity? Bent space. Whatever that is, it's a bent geodesic. That somehow electrons and protons can see it. We can't see the geodesic, but they can. Sure they can. I mean, lots of empty answers. But, yeah. It seems incredible that they could be... I mean, they could make a mistake this egregious, this silly. But they did. And sooner or later, you have to start saying, oh, yeah, okay. Reluctantly, I will concede they really screwed it up. You're just going to have to admit it eventually. So why don't you get to it already? Because it's obviously a mistake. There's obviously not 4 times more energy there, and there's obviously not twice as much energy here. There's the same amount of energy. It's just a big V and a little mass, or a big M and a little v. All you can do is rearrange masses and velocities. There's nothing else. There's no squared terms. There's no half terms. There's just mass and velocity. How many little bits do you have, and how fast are they going? That's energy. That's weight. That's pressure. That's heat. That's everything to do with energy. Momentum is energy. Alright, so we'll call that enough of a video and such. So, yeah, we'll just get to the ending, I guess. I don't think there's anything else to say. Yeah, that's good enough. Alright, so till the next time, this has been a DraftPhysics.com video presentation. Also debatephysics.com, but I still can't find anybody willing to defend conventional physics. I am offering to pay you reasonable fees for your time if you think you can manage to make an argument to my arguments and such. But no takers yet.